So welcome students. Let us look at the topic of logarithms. So the first question that we need to answer is, what is logarithm? What is logarithm? And how do I understand it? How do I understand it? So these are the basic questions that we are going to deal in this video. So first, to understand logarithms, you need to know basic knowledge about the topic of indices or exponentiation. So I hope you know some basics about indices. So indices is a very basic topic that you learn in your lower classes. For example, what is 2 power 1? 2 power 1 is equal to 2, right? And if I ask you what is 2 square, it's very easy to answer. 2 square, you have already learned it as 4. Similarly, what is 2 cube? I'll write some expressions. I'll write some equations in indices. So 2 cube is equal to 8, right? 2 power 4 is equal to 16, right? Similarly, I'll write some powers of 5 also. So 5 power 1 is equal to 5. 5 square, you know it as 25. 5 cube, you know it as 125. 5 power 4, you know it as 625. So it's very easy to raise a positive number to integer power. I can also write 2 power 0, 2 power minus 1 also if I want. That's very easy to find. Now, so these are some equations in exponential form. And in this exponential equation, we have some terms. This number is called the base. And this number is called the power, right? So we raise a base to a certain power. Or this can also be called exponent. Same. So also called exponent. This is also called index. 2 raised to the power 2, 2 raised to the exponent 2, 2 raised to the index 2. Similarly, 2 raised to the power 3, 2 raised to the exponent 3, 2 raised to the index 3. So you can, whatever you want, you can tell. So 2 raised to 3 is equal to 8. Similarly, 5 raised to 3 is 125. Now, these are the equations that you come across in the topic of indices. And we also learn the properties of indices. Now, I'll ask you a similar question, but in a reverse way. The question is, what is the power of 2? What is the power of 2 present in 2? What is the power of 2 present in 2? If I ask you this question, what will be your answer? So in 2, what is the power of 2 present? Or to what power 2 has to be raised to get 2 as the answer? So we know that 2 has to be raised to the power 1. So power of 2 present in 2 is 1, or power to which this base 2 has to be raised to get the answer as 2 is equal to 1. Now, can I write the same equation like this? What is the power to which the base 2 has to be raised to get 4 as the answer? So what is the power to which base 2 has to be raised to get 4 as the answer? The answer should be 2. And if I write the same thing here, what is the power to which base 2 has to be raised to get 8 as the answer? The answer should be 3, right? 2 has to be raised to the power 3 to get 8 as the answer. Similarly, let me write this expression for each and every equation. So you have to be very careful and you have to observe this equation very carefully. What is the power to which the base 2 has to be raised to get 16 as the answer? The answer should be 4. Now let's do the same thing here. So what is the power to which the base 5 has to be raised to get 5 as the answer? The answer is 1. what is the power to which base 5 has to be raised to get 25 as the answer? The answer is 2. What is the power to which base 5 has to be raised to get 125 as the answer? The answer is 3. Similarly, the power to which the base 5 has to be raised to get 625 as the answer is 4. So I hope you have understood this converse way of writing the same equation. Now, if you want to understand logarithms, you just need to understand logarithm as exactly same as this power. So log is exactly same as this POW that I have written. So what we do in log is, if I write log of 729 to the base 3, if I ask you what the value of log of 729 to the base 3, this is exactly same as the power to which base 3 has to be raised to get 729 as the answer. So we know that this is equal to, so 3 power 4 is 81, 3 power 5 is 243, 3 power 6 is 729, that is 3 has to be raised to the power of 6 to get the value, to get the answer as 729. So if you can understand what this power is doing, this is same as the log term. This is what log actually does. It calculates the power to which the base has to be raised to get the answer, which is this number. So I hope you have understood what logarithm basically does. So now let us go forward and look at further understanding of logarithms. So the most basic formula that you need to master in logarithms is how to convert a given equation in exponential form to the corresponding equation in logarithmic form. So if you have an equation a power x is equal to y. So a raised to the power x is equal to y. So this is an exponential equation. So this can be written in logarithmic form as log of y to the base a is equal to x. That is, the base a needs to be raised to the power x to get y as the answer. So a raised to power x gives y. The power to which a has to be raised, the power to which base a has to be raised to get y as the answer is equal to x. So these two equations represent the same information. And as you can very clearly see, the base in the exponent form becomes the base of the logarithm. So it is called the base of the logarithm. Just these two numbers will get reversed. So a power x is equal to y. So log y to the base a becomes equal to x. So this is how the logarithmic conversion looks like. If 6 power 2 is equal to 36, if this is the equation in exponential form, the corresponding logarithmic form is log. This base remains the base of log. This is the base of exponential. This is also base of logarithm. The base does not change. Just these two numbers get exchanged. So log to the base 6 of 36 is equal to 2. That is, 6 has to be raised to the power 2 to get 36 as the answer. So if you have something like 4 power 3 is equal to 64. So the logarithmic form of this equation is log 64 to the base 4 is equal to 3. Log 64 to the base 4 is equal to 3. So similarly, if you have log 100 to the base 10 is equal to 2. So what is the corresponding exponential form? 10 power 2 is equal to 100. 10 power 2 is equal to 100. This is the exponential form. This is the logarithmic form. Right? Next, similarly, you can write the corresponding logarithmic forms and exponential forms of any equations. So now let us look at some examples. So if I asked you to find these values, so what is log 64 to the base 2? So what I am effectively asking you is to what power should 2 be raised to get 64 as the answer? So initially what we do is we convert this equation into exponential form and try to solve it, because exponential form is much more familiar than logarithmic form for now. But once you have understood logs, you will be able to do it directly. So for now what I do is I'll assume this as x. So log 64 to the base 2, let it be equal to x, and this implies if this is equal to x, then if you convert this into exponential form, 2 power x has to be equal to 64, and this implies 2 power x has to be equal to 2 power 6. 64 is 2 power 6, and this implies x is equal to 6. That means the value of log 64 to the base 2 is equal to 6. And this is very clear initially also. 2 has to be raised to the power 6 to get 64. We know that. Next, so if you have something like this, log 10 power 6 to the base 10. So again, the question is to what power should 10 be raised to get 10 power 6 as the answer? The answer is, I hope, very clear. The answer should be 6, right? 10 has to be raised to the power 6 to get 10 power 6. So that's very clear. You can also do it by the above process. Get 6 as the answer. Next, what is log root 2 to the base 2? So to what power 2 has to be raised to get root 2 as the answer? So till now we are having nice natural numbers in this place, but it's not necessary that always this has to be a natural number. This can be rational, irrational also. So what is log root 2 to the base 2? Let's say let it be equal to x, and this implies the exponential form of this is 2 power x has to be equal to root 2, and this implies 2 power x has to be equal to the root 2 is nothing but 2 power half, and this implies x is equal to half. This implies x is equal to half. That means log root 2 to the base 2 is equal to half. And now let us go to this question. What is log root 3 to the base 9? To what power 9 has to be raised to get root 3 as the answer? Again, initially let it be equal to x. This implies 9 power x has to be equal to root 3. And this implies 9 is 3 square. So 3 square power x has to be equal to 3 power half. 3 power half. This implies 3 power 2x has to be equal to 3 power half, and by equating the power, because the base is same, the powers has to be same. 2x is equal to half. This implies x is equal to 1 by 4. So that means the value of this is equal to 1 by 4. This 9 has to be raised to the power 1 by 4 to get root 3 as the answer. Next, finally, let us take log 125 to the base root 5. So again, let it be equal to x. This implies root 5 power x has to be equal to 125. So let us express both of them in powers of 5. This implies 5 power x by 2. Root is power half. 5 power x by 2 is equal to 5 power 3. 125 is nothing but 5 cube. This implies x by 2 is equal to 3. And this implies x is equal to 6. So the value of log 125 to the base root 5 is equal to 6.